Swayam Prabha. Digital India. Educated India.
A very good morning to one and all present here. Today, Sanvi Malhotra and I, Vanya Khanna from grade 11 of Sun City School. Wait. Where's Sanvi? Sanvi?
Oh God, so sorry Vanya, so sorry. Good morning everyone. I was so busy blowing these balloons, I completely forgot about our presentation.
This is not the time to play around, Sanvi.
I'm not playing around, Vanya. This was my grand and, well, it turned out not so grand. But this was my entrance for our presentation. And these balloons aren't here to play around with. They're common examples of Newton's third law of motion.
What? Newton's third law? In the flying of a balloon? How do you see that happening?
Let me show it to you, and if you still don't understand, then I'll just explain it.
Okay. Still
Let
don't
me
get
just
it.
explain it. Okay, so what we just saw was when the air is released out of the balloon, it exerts a downward force. This downward force has an opposing reaction on the balloon, which causes it to move upward and twirl around in the air like it just did. Just look at it once again and hopefully you'll get it this time. See?
Oh, I get it now. But what are you doing with that skateboard?
It's not a skateboard, Vanya. It's a waveboard. And it is another
bad.
really easy explanation of Newton's third law of motion. When I ride this waveboard, I push the ground in a backward direction. The ground then pushes the waveboard and me in a forward direction, bringing me into motion.
Oh, I get it now, but you didn't really come into any motion there. You didn't even ride the waveboard.
Okay, so action and reaction is easy, but the balancing part of the waveboard, not so much. Whenever I do try to ride it, I end up falling flat on my face. And while riding the waveboard is an example of Newton's third law, falling off of it, maybe that's to deal with the second law of motion. So let's not get into that.
But let's pause for a minute. You said Newton's third law. I don't really remember the exact statement, but I remember from 9th grade that it's got something to do with action and reaction forces.
God, Vanya, you don't remember anything. This is what online school does to people. Anyway, Newton's third law states that every action has an equal and opposite reaction, which you just observed in the balloon and the waveboard. See?
Oh.
Physics is really easy, Vanya.
Sure, that was a good one. Nice joke.
Speaking of nice jokes, I heard an amazing one a few days ago, and you have to listen to it. Okay, so there was a sheep that was walking on the road, and Newton came across the sheep. Newton realized that to stop the sheep, he had to apply an external force on it. And that's when he derived the first law of motion. An object in motion continues to stay in motion until an external force is applied on it.
Nice joke.
Wait, it's not over. Newton is a curious man. When Newton decided to see what would happen if he kicked the sheep. And he did. And you know what the sheep replied with?
Not really.
Meh, F is equal to MA.
Oh God, Sanvi. Not today.
Wait, before you decide to leave. When Newton kicked the sheep kicked Newton back. And that's how he realized that every action has an equal and opposite reaction.
Obviously.
See? Now you get it.
Oh God, I think I do.
I think you've gotten a little off topic. So, I may not be able to ride the waveboard here, but I do have a few secret talents like archery. I'm a really good archer.
That is so cool, Sanvi. Can you show us how it's done?
Well, how about instead of me explaining it this time, you try and explain the explanation of Newton's third law of motion in archery.
Oh, okay. So what you're trying to say here is that as soon as you pull the arrow, your hand exerts a backward force on the string, and the string in return exerts a forward force which causes the arrow to get launched in the forward direction.
Exactly. What Vanya means to say is, this is the action and this is the reaction. So let me tell you about basketball. Basketball is another sport that I'm really good at. And it's interesting to see how physics is involved in the bouncing of a ball as well. Just observe. When I bounce the ball, equal and opposite reaction. That's amazing.
Okay. I noticed something strange here. I mean, I do see the action and the reaction happening here, but it's not really equal, is it? I mean, the ball isn't really rising back to the same height from which it was thrown.
That's an interesting observation. That happens due to the imperfect elasticity of the ball and due to the air resistance that acts on the ball when it tries to attain its original height. If the same experiment would be to carried out in a situation with vacuum and a hypothetical perfectly elastic ball, then the ball would rise to the exact height that I drop it from.
Oh, that makes it much easier to understand. And I think we're totally done with sports now. I mean, archery, using the wave board, and even basketball. What about people who are not really a big fan of sports? I mean, is there any simpler example, like something as simple as walking?
Walking! There you go. Now you're getting the gist of it. Newton's third law can be applied in walking as well. Try it. Go ahead.
Okay. Let me try this. So, you mean when I'm walking like this, my foot exerts a force in the backward direction on the ground, and in return, the ground exerts a forward force on my foot, which causes me to walk as a result.
Exactly. I think you're finally understanding the third law of motion. But you know, walking is boring. I like soaring high up in the air, much like birds do. You know, Newton's third law of motion can be applied in the flapping of the wings as well.
Oh, okay. I think so. Can you please explain that better?
Okay, so when birds flap their wings, they push the air surrounding them in a downward direction. What are you doing, Vanya?
I'm just illustrating what you're saying. I mean, the birds flapping their wings and action and reaction forces. Do you not see it here?
Just when I had some faith in you. It's okay. Let me continue. So when a bird is flying, when it flaps its wings, it pushes the air surrounding it in a downward direction. This air then exerts an opposing force that causes the bird to move upward. That's how they fly at such great heights.
Oh, okay. So, enough about soaring high in the air. I like to personally shine in the water. Let's talk about water. Have you ever seen a swimmer? Okay, as you can see, what happens is that the swimmer's hand, it exerts a force in the backward direction on the water, and in return, the water exerts a force on the swimmer and causes the swimmer to somewhat propel forward.
Water. I really need some water. All this speaking is making me really thirsty, Vanya. This well is here for a reason. Let's put it to some use now. What is this?
I mean, that is one strange thing that's happening, but do you not notice anything else also that's strange? I mean, you're pulling the rope downward, but the bucket of water is as a result rising up. Why so?
I think that can also be explained with, surprise, Newton's third law of motion. And also this little pulley here. When I pull the rope downwards, that is the action. And look, did you observe the reaction? The bucket is coming upward, all thanks to the rotation caused by our pulley. Let's show again.
Okay. Let's see the action and the reaction.
And reaction. See, it's a beautiful process.
Oh, I see it how.
You know, Vanya, pulleys remind me of H.C. Verma. Favorite book for physics ever.
Do not get there, Sanvi. Not H.C. Verma again. His monkey questions have haunted me at 3 a.m. in the night for 2 years. Not again.
Well,
you can't be
Vanya,
talking about that.
I think the monkeys are back to haunt you,
No,
Vanya.
Sanvi, please don't.
Come on, hold one.
Okay.
I know H.C. Verma has caused all of us to have some sleepless nights with his questions, but you gotta admit, his examples are really creative. Just see, here we have two monkeys, and one of them has a banana, and one doesn't.
So you mean yours is the greedy one and mine is the lucky one?
Yes, so if my greedy monkey wants your banana is attached to this rope, let's see how exactly he would go about it. Okay, how exactly do I get there? Audience, any suggestions?
Maybe the monkey can try climbing up and going to the other side.
Okay, that's a good suggestion. If the monkey tries to climb up, oh, do you see what happens? Due to the action of climbing up, the monkey on the other side is pulled upward. Action and reaction. Newton's third law is back at it, Vanya.
That doesn't really help the monkeys.
Oh, that's true. What can we do? Oh, gravity. It acts on us all the time. Just let go of the monkey, Vanya.
Let's try.
Well,
so maybe they can now just fight on the ground for their bananas.
Well, I guess they're free to do so. God, move this well aside. The lack of water is pissing me off. I'm really sorry. Please just let me have some water. Excuse me,
Oh,
audience.
Sanvi, you and your interruptions.
Vanya, The mechanism behind this bottle is interesting. You know, how...
No, son. Wait. It's just drinking of water from a bottle. You can't get physics in there too.
Vanya, trust me when I say physics is in everything. You know, the straw pulls the water upward. That reminds me of something we did in 10th grade, something about plants, something transpiration or something.
We did do transpiration, but transpiration is directly related to capillary action and the ascent of sap. That's biology. This is a physics presentation.
That's transpiration pull, silly. Transpiration pull and ascent of sap is what Vanya was trying to talk about with her capillary action fancy words. Anyway, before we get to capillary action, Newton's third law of motion can also be applied in the transpiration pull or the ascent of sap. When transpiration goes on in the leaves of plants, it generates a lack of water in the leaves, which is the action. This lack of water then causes the water from the roots of the plant to be pulled upward. That's the reaction. See, there's no biology, physics, and chemistry in nature. It's all just combined under a big umbrella term, science.
Oh, okay. I think we've blabbered a lot for the day. Let's just wrap up this presentation now. Oh, 1 second. I think the audience might be wondering why we have this UFO lying around.
Oh, okay, of course, we forgot about that. So, Newton's third law can also be applied in the launching of a UFO. And that's a question that we leave the audience with to test your knowledge. Thank you.